Hi, and welcome to Tom Kennedy Science, and I'm your host, Dr. Tom Kennedy. Today, I'm continuing on my series on climate change. And what I want to talk about now are the consequences of climate change. So we've talked about how we know climate change is happening, how we know we did it. Well, if we did it, that means we should probably fix it, right? But some people are like, okay, so, we're causing climate change. We did it. We're the culprits, but it's not that big of a deal. And then there are others out there going, oh, it's going to be the end of civilization. It's going to be the end of humanity. It will doom us all, doom and gloom. What I think we need is a real scenario. It's like, really, what are the scientists telling us that's going to happen? And then once again, to understand the concepts of climate change is complicated for us, right? When we look into the past, we can get an idea. What were global sea levels like? What was the average climate like? What was diversity like? As we go into our next climate change, how's that going to affect us? So we do have some data to help us figure this out, but it also gets really complicated because there are 7.8 billion people on this planet, and by the time climate change is already really going, but soon we're going to have over 8 billion people on this planet. That's a lot. So the consequences of climate change can be difficult to predict for everything. But let's take a look based on what we know. And when we go back in time, every time there's major climate change, it's accompanied by a mass extinction. Now, a mass extinction occurs when over half of all your current diversity goes extinct, is gone, within a relatively short period of time. You can think about the dinosaurs going extinct 65.5 million years ago. It probably didn't take very long for them to get wiped out, maybe less than a few decades. The end of Permian took about 100,000 years. So how do we know we're in a mass extinction now? Well, we have some pretty good evidence to support that. When we look through the fossil record, we see that the extinction rate is about one species goes extinct every 100 years for every 10,000 species. That's a background extinction rate. So there's always some species going extinct and new ones evolving. Now we know, currently documented, at least 50 species per 10,000 are going extinct every 100 years. That is 50 times the background extinction rate. And that sampled of the species we know is extinct is most likely a grave underestimate. And not only is it underestimated, there's some other exacerbating problems with that I'll come to in just one second. But there are estimated extinction rates as high as 6,500 species for every 10,000 every 100 years. That's a 65% extinction rate, which is, that's faster than the dinosaurs going extinct. I'm not sure that one is accurate at the moment, but I think going forward, that 6,500 species, or almost 65% of all species going extinct in the next few hundred years, is very plausible. And that would be one of the fastest extinction rates we've ever seen on this planet. And the reason why I believe the higher estimates is because right now, even though we don't have that many exact extinctions, everything is declining. Well, not everything, but most populations of animals are in steep decline. Let's look at vertebrates. Since 1970, now that's only been a little over 50 years, my lifetime basically. 52% of all birds, mammals, fish, reptiles, and amphibians are declining. Okay, we haven't lost that many in terms of species, but we've lost like half of our vertebrates, half of the total number of vertebrates on this planet. So that's amazing. If you just go back 50 years, we would have had twice as many birds, and mammals, and reptiles, and amphibians. In fact, in the United States alone, we're down like 3 billion birds from the 1970s. And I'm a birder, and in the last 2 decades that I've been birding, 3 decades, I've seen these declines. It's harder to find the numbers of birds that I used to see when I started in the 1990s. But these declines are not limited to birds or vertebrates, it's animals. And in fact, there are some scary studies showing that insects are rapidly declining. In fact, all invertebrates could be rapidly declining. Okay, I use the word all again, but most invertebrates. And a lot of animals eat invertebrates. So if they're declining, everything that eats them is also declining, and all the things that depend on those invertebrates would also be declining. And of course, these declines are not limited to animals living on land. Well, of course, fish don't live on land, right? But in our oceans, they're slowly becoming more acidified, or the pH is lowering because the oceans are absorbing a lot of the carbon dioxide that we are emitting. And in fact, it's absorbed almost half of the CO2 emitted through the burning of fossil fuels. That is lowering the pH of the oceans. And that is making it harder for a lot of organisms to survive. So there are these things called corals and snails. Well, corals build reefs. Now, reefs account for about 1% of the total surface of the ocean. And on those coral reefs, we get about half of all of our ocean's diversity is found on 1% of the ocean. And with the ocean becoming acidifying, the animal, the coral that makes the reef, can no longer secrete calcium carbonate as easily. So ocean acidification and ocean warming is causing major die-offs of these reefs. I mean, I think we've lost like 40 or 50%. You can only imagine how that is decimating our ocean's diversity. So land and ocean, we're nailing ourselves. And then you might ask the question, well, why do we care about animals? Why do we care? Why do we care if insects and birds decline? Well, how many of you like strawberries, blueberries, blackberries, pumpkins? Oh, you're in New Mexico. How many of you like your chilies? How about green chili? How about habaneros? How about jalapenos? How about bell peppers? How about those of you in Florida? Well, you don't have to be from Florida, but I love citrus. All of your fruits that you eat, plants set fruit when they get pollinated by an insect. And that goes also for all of our grains too, like rice, barley, and wheat. Those seeds are set when some insect pollinates the flower. So you can imagine that if we lose all of our pollinators or they become much more rare, then all of a sudden this is going to start to have major impacts on our agriculture. So yes, it can affect us economically. Also, species diversity creates more complex ecosystems that are resilient to change. They also provide ecosystem services. In addition to pollination, clean air and water. Yes, plants really do clean the air. I know there was a politician, president back in the 1980s said trees pollute. God, I don't know where you can make that up. Yeah, that was actually said. At any rate, I'm not going to go into the politics of that right now. I'll save that for my next video. And also, half of our pharmaceuticals come from plants. So if you're wiping out rainforests before you can even catalog these plants, like in the movie Medicine Man from the 1980s with Sean Connery, he's like, I found the cure for cancer and it was gone. It's gone. Just the area where he found it was bulldozed over to grow cattle or something. So yeah, and in fact, some of our cancer medicines come straight from bark of rare yew trees. You like aspirin, that comes from the bark of a willow tree, right? So we do get medicines from trees and plants. Also fungus too. You never know. So yeah, there are real economic value and benefit to intact ecosystems and maintaining ecosystem diversity. Now, others of us, I find intrinsic value in diversity. As a naturalist, I enjoy getting out into green areas. And in fact, so many studies are showing, hey, you feeling down, feeling a little blue? Go for a walk. Not just go for a walk where it's green, where there are trees. It helps people feel better. It improves our health. It improves our mental health. And also the intrinsic value. Some of my best times ever have been with my friends traveling around birding or going to the tropics and finding rare animals. This helmeted iguana, I know it's Cordyphanes, I always forget the common name. I found this lizard on the side of a tree in Costa Rica one night. How cool is that? It's one of the coolest things I've ever discovered in my life. And just even today, like 10 years after I found that lizard, I still get excited thinking about finding it and being with my friends. So there is also this intrinsic value that diversity offers us. But let me get back to these other consequences of climate change. They don't just cause mass extinctions. And of course, we're in the sixth mass extinction now. But climate change doesn't just warm the weather or warm the planet up on average. It causes changes in extreme weather. So we get these like record cold. Yes, you can have record cold in a global warming situation. I know it's weird, but it's part of the polar vortex and the lessening of the temperature gradients between our region of the world in North America and the poles. So this was last April. It snowed. It was record late snow, and then it snowed again on September 9th, followed by record warmth. That's not normal. Texas, you had a pretty big deep freeze in February. It did not do you very well. Okay, not just extreme cold or warmth. How about major flooding? So we get intensification of thunderstorms. You might not have a regular thunderstorm come through every 2 or 3 days. You might have one come through every 2 weeks, dumps the same amount of rain that 4 thunderstorms would dump. And then now there are these more intense storms that cause increased flooding. And that doesn't soak in. That doesn't help your plants out as much. So that's a tricky thing, right? You're looking at your rainfall values and going, oh yeah, we got the same amount of rain. Yeah, well, it's not as good if it comes every 2 weeks versus 3 times a week, or once a month versus once a week. These things cause stresses on our ecosystems. Hurricanes. Hurricanes are driven by warm waters. If you have warmer waters, you will have more storms. You will have more intense storms. Now, can I attribute any one hurricane to global warming? The answer is of course not. But what we can attribute to hurricanes are more rapid intensification, because it's a heat transfer. If you've got warmer oceans, that is more energy. And if you've got warmer oceans, you can have more rapid intensifications. And in fact, you can even calculate, based on energy, how 2 degrees warmer sea levels lead to more intense hurricanes like Harvey's. Yeah, Harvey may not have formed because of global climate change, but Harvey became stronger because the Gulf was warmer. And then because we've altered our climatic patterns and our wind flows, guess what? It stalled out over Texas. Rather than moving right along, it just sat there and rained and rained and rained and rained and rained and rained and caused about $125 billion in damage. Hurricane Iota. This was what, last year? This was a record-setting year in 2020. We had the most number of named storms. We had 5 years of Category 5 storms. We had a Category storm Iota, which formed in November. It was the latest storm that became Category 5 to ever form. So, wow, once again, warming waters is exactly what we expect. We intensify climate patterns. Not only do we see an intensification of storms, whether it's a thunderstorm or a hurricane or a cold snap, but we see this intensification of like drought and heat. So this is the Rio Grande. It goes dry south of Albuquerque every single year. Most people don't realize that because most people live in Albuquerque. It doesn't go dry in Albuquerque. But soon, it almost certainly will. In the western U.S., from California to West Texas, I've been out here for almost 20 years. And it seems like almost every year there's a drought. So we're seeing this mega drought that has been developing over the entire West, and especially the Southwest, over the last 20 years. And this little bit hotter, that if you're just a little bit hotter, a degree or two, you're like, what does a degree or two matter? Well, a degree or two, even if you have the same amount of rain, can be the difference between drought and not a drought. And the reason why is just a degree or two difference makes a huge difference in the rates of evaporation. So if you're at an average of 92 degrees and you're getting, your 12 inches of rain in the summer, you may not be in a drought in the West. But if you're at 96 degrees or 95 degrees, which is what we're seeing, and you're getting the same amount of rain, you're in a drought. And this chart by the U.S. Drought Monitor just shows back in November, and we're still here. We're still in a major drought, and we have been for a long time. And these droughts are causing serious problems record fires. The West is burning up. Not only is this record drought causing more wildfires, it's actually killing our forests without the fires. We're seeing trees die because of drought and bark beetles. They're also dying because they're not getting cold enough in the winter, and a lot of these pine beetles and bark beetles can survive. And I'll have another video about that. So you might be like, okay, extreme weather. Well, we can deal with that. I can turn my heater up. I can turn my AC on. I can go to the beach. I can do all these things to keep cool. Okay, so we lose some forest. Yeah, it's going to cause timber to spike, but I'll be okay. Well, do you think that's true? Well, there's some real problems here. How about damaging crops? Extreme rain floods them out, kills them. Extreme drought obviously kills them. But did you know that too much rain will actually drown out your crops? How about a massive hailstorm? Believe it or not, hailstorms can wreck a crop. And this is important for multiple reasons. Humans are nearly 200,000 years old as a species. We've only had civilization for less than 10. And why less than 10? Why 95% of our existence there was no civilization? We're just hunter-gatherers? Well, end of the Ice Age. Starting about 11,000 years ago, the Earth entered into one of the most quiet and predictable periods of climate it's had while humans have been here. What did we start doing? Agriculture. So we had the agricultural revolution that started around 10,000 years ago because we had predictable climate. And in fact, we celebrate our winter solstice, Christmas, Hanukkah, right? We have a spring equinox, Easter, other religious holidays. These all fall around the equinoxes and the solstices. And the reason why is because you could predict when to plant, when to harvest. That's important. And the problem here is if our climate begins to shift, then areas where we grow crops, we may no longer be able to grow crops. So now we've got to move our infrastructure to another place to grow them, like moving it northward. That's something maybe we could engineer. Might double or triple the cost of your food. But the other problem is more significant. Yeah, we can shift northward and where we grow crops. But if we lose the predictability of our weather, if we have late frost, early frost, drought, or too much rain, that right there can wreck our crops. And by wrecking our crops, now all of a sudden the cost of food goes up because it gets harder to grow them because we live in unpredictable weather patterns. So that's a real problem with climate change. More problems. Coastal flooding. All right, you live in the interior of a country. You don't care about coastal flooding. I mean, who cares about coastal flooding living in New Mexico? Well, I'm from Florida. This shows South Florida. The last time we were at 400 parts per million, sea level was 20 feet higher. That's Miami underwater. That will cause not only economic loss of people's property, it will also begin to displace people as well. And this is what coastal flooding looks like. I took this photo of one of my favorite places. You can see that was once a pine forest. It's gone. And you might say, well, hurricanes and storms are always moving beaches around. And yeah, that's true. Except that all the beaches in my area look like that now. Coastal flooding, economic damage, and this causes displacement of people. And you're like, oh, these people from Miami, they can just move out of there and go somewhere else. Well, can they? So now we're starting to see climate refugees. In areas that could once grow crops, they're too dry. People move. That causes problems. Or you're a coastal area. You live on a small island. Your island is now flooded. It can no longer hold you. Where do you go? And that's a problem. So now we're starting to see people move around because they're now climate refugees. And, this leads to all kinds of problems. And I don't want to get into it because I'm not an expert on the climate refugee problem. Okay, there's more. I know this is dragging on, huh? This is kind of depressing. More cost to climate change. We have lots of health issues. I teach a biology for health-related sciences. So as it gets hotter, people will die of heat exhaustion. If it gets too cold, people freeze to death in their homes, or they attempt to warm their home and They get carbon monoxide poisoning. As we get other problems can lead to cardiovascular problems, mental health, malnutrition because we don't have good crops. If we have flooding, that might lead to water issues where you get cholera. You see? Okay, and here's one of my other ones. As the climate warms, a lot of insects that are limited by cold weather can move northward. And some insects, like the most dangerous animal on the planet, which is the mosquito, and certain mosquitoes can start moving northward and they start carrying their diseases with them. So a lot of diseases that, hey, in North America, we've either eradicated or we don't get them because we're too cold. Well, if we warm up, that will change and we'll start seeing diseases and parasites that are confined to the tropics spread northward. And that causes more problems. As you can see, global climate change is going to cause us a lot of problems. Is it going to end civilization? This is me speculating. Probably not. Is it going to end humanity? Probably not. But it is going to cause human suffering. It is going to cause economic loss. It is going to cause loss of biodiversity. And we're going to end up paying for it one way or another. We're either going to do things to mitigate our fossil fuel emissions and try to slow it down, or we're going to pay for it even 10 times more if we continue down the path we're going. And people always ask me, what can I do about climate change? Well, one thing you can do is vote. We have to have policies from the top down. You can always act locally, think globally, right? You can do small things like recycle, walk more, which is way better for your health than driving a lot more, and think about the foods you eat. Plant-based diet is way more economical than eating a meat-based diet. Now, I'm not saying go and giving up meat and everything that's fun in life. I think we need to be happy. I'm going off on a tangent here, which is okay. We need to be happy. We need to live our lives, but we can all make small choices to use less and consume less. But the reality is we need our government to make broad-scale changes and be a worldwide leader in climate change. And we do that by voting for candidates that acknowledge that climate change is a threat and that we need to do something about that. Okay. Well, there you have it. There's the consequences of climate change. As an individual, do what you can, but the reality is we got to make big changes at our government level, and we do that by voting. Voting for candidates that believe in science, whatever party that is. Okay, till next time, Tom Kennedy Science.